So far, every time you've dealt with an index expression, you've been asked for something that might have a base, and then you've been given also the exponent or the index number, and you're asked to find what that would equal. So we know that's 2 times 2 times 2, which is 8. So the unknown here in an equation form would be to say, what is this expression equal to? And then if we were to solve that, we would say, oh, I know, x is equal to 8. Now, what logarithms allow us to do is to ask this question in another way. So if I was to say, ask you 2 to the power of something, let's call it x, because it's an unknown, 2 to the power of something is 8. Solve this for me. Now, I've asked for a different unknown, haven't I? And it's quite a simple question if you know that 2 to the power of 3 is 8. But the big difference between these two equations is that when you're finding the answer to x over here, x is really nice and simply all by itself on one side of the equation, and the other side of the equation has some numbers which you can put into your calculator or simplify in a variety of other ways to find that x equals something. The problem with asking the question this way is that the x is actually not sitting all nice and alone on one side of the equation, it's tied in closely with this 2. And so it becomes hard for us to understand what to actually do with the 2 and the 8 to work out the answer. Now this one's simple because we know that 2 cubed is 8, but what if it was numbers that we didn't know? It becomes quite hard to solve. So logarithms allow us to rewrite this question so that the x is all by itself. And the way that we do that, let's just label the parts of this. We have the base here, that's the 2, and we have the index number here, that's the x, and the whole thing is a power, isn't it? So the 8 really is a power because it's equal to everything on that side of the equation, so it's kind of the power. Well, when we rewrite this as a log, we write log, which is short for logarithm. We start with the base, and it goes down here, it's written as a subscript, a little bit lower than the log. And then the x comes over the other side of the equation. It's almost like I'm writing things sort of backwards, you'll see why in a minute. And then the 8 ends up over here. Now the way to think of this is, we have the base down here, and we have this is the power, as it was before, and what we have here is the index number, or the exponent. And the beauty of it is that the x is now sitting all by itself. Now, the way to understand what a logarithmic expression means, or a logarithmic equation I should say, it's got an equal sign in it, is you start at the base and you say 2 to the power of whatever is over here equals this. And this is the way I think of it, sort of like it goes around in a circle to ask a question. So we can simplify that now and come up with a bit of a basic law or a rule, if you like. We could say that if log of, now let's, instead of doing 2 to the power of 3 equals 8, let's just use some general numbers. If we say we've got log with base a of some number x and a are just numbers, and that all equals some other number y, then we can rewrite that. So all of that means a to the power of y equals x. So I call this telling the story. As you look at a log expression or equation like this, tell the story and say a to the power of y equals x, and you can rewrite it like this. So let's put a nice big box around that. That's a rule that we need to memorise and understand fully. So now we need to practice this and get comfortable rewriting index expressions as logarithms or rewriting logarithms as index expressions, because you need to be able to go between one and the other. So these are true statements. 10 cubed is 1,000. We can rewrite that equation though and say, we start with the 10, the base down here, 10 to the power of 3 equals 1,000. Now I write it around like that because I'm telling the story. Sometimes you've got to leave yourself a bit of space to write down your power, if you like, over here, to end up there. But remember, I'm telling the story 10 to the power of 3 equals 1,000. And as I do it, I go round in that order to remind myself that that's how I tell the story here. 10 to the power of 3 equals 1,000. I say the numbers in that order. So over here, I tend to write them in that order too, because it reminds me of what goes where. So over here, I write log 3 to the power of 4 equals 81. 3 to the power of 4 equals 81. That's how I write that one. Going back the other way, tell the story the same way. Here, use the arrows if you need to as you're learning. 2 to the power of 4 equals 16. That's what that means, tell the story. So that becomes 2 to the power of 4 equals 16, and I can write it like this. And down here, telling the story, 3 to the power of 3 equals 27, can be written like this.